The Earth is so fat. How fat is it? Well, let's see if we can science that. Yesterday I did a video on this that was a lot longer. I promised a shorter one. I'm going to do that right now. I'll put a link up to the long video up there if you want to watch that. Let's just do the crash course. First, let's find us some images. I recommend the Epic camera on the DSCOVR satellite. This is it, Epic DSCOVR. That is, if you don't know about it, that is a great place to find images of the Earth. Full frame images, not taken as composites. These are taken from far enough away that you can get the whole Earth in one shot, and it's always on the daylight side. So always get a nice full image. And there are a lot of them. It just takes shot after shot after shot after shot, and here they are, available directly on the website. Now we want to compare equatorial radius to polar radius, and we can make our job even easier on that by taking it on an equinox. The most recent equinox is going to be, choose the date here, September 22nd. All right, now you can see on September 22nd, the Earth just happened to be right there with the equator pointed at the sun. And then during that day, we could pick a time anytime we want. Let's pick a time when North America was well in view. Why? Because I live in North America. So yeah, let's take a picture of myself right there. Okay. That's what I want. That's good. Any of these should work just fine. And you don't need an equinox. I'm just trying to be, super anal about it. So I'm going to download that image. Here it is. Full resolution. Copy it. I'm going to put it into GIMP. Here we go. There's the image. Let's now measure the thing. I'm going to compare the equatorial radius to the polar radius. So let's get in and measure. Let's measure the equatorial radius. Here's my measuring tool. I'm going to actually measure the diameter. Measuring the diameter in pixels on the original source image. Okay, and there we are. Right down here, we have 1703. So equatorial radius, 1703 pixels. Compare that with the polar. What's going on in the polar radius? And if this is perfectly round, it'll be 1703 again. Let's check it. Here we go. Coming down. Any minute now. Takes a little longer, top to bottom, because it doesn't scroll as fast. Okay, here we are. And there it is. And the number is 1698. So 1703 by 1698. So it is not round. How fat is it? 1703 minus, I'll use the mouse so you can see there, minus 1698. It is 5 pixels wider than it is tall. As a fraction, divided by 1703 is, there it is, 0.3%. It is exactly 0.3% wider than it is tall. The expected number is 0.33. We got 0.29. So, a little bit off. How much off are we? That's something worth exploring. If you take 1 pixel out of that, like add 1 pixel. Say instead of 5 pixels, if it was 6 pixels divided by 1703, that would then be too big. And that's 0.33 instead of 0.35 instead of 0.33. So, yeah, we're within 1 pixel of exactly the size that it's supposed to be. So there you go, verification straight from the horse's mouth. Pretty easy, done and dusted. That's how you do it. Keep in mind, your mileage may vary depending on what image you choose to measure. Some images online are not actual single frame photos. We need to make sure that they are. You'll need full lighting on the image, and it has to be high enough resolution to be of any use. Here are some results I found from yesterday. Some of them are a little suspicious. If you know anything about those, please drop me a comment. What we measured today from the DSCOVR satellite was bang on the accepted value. As always, let me know if you have any questions or comments about this material.